Welcome everybody, it's King and Shu. I'm here to show you guys how to solve any type of technical problem, coding problem, hardware, software, whatever it is. Let's go ahead and solve any type of coding question you may have in an interview, in business, by yourself, with a group, in school. You may need to submit something to GitHub or whatever type of version control system you may be using. But in general, this is how you solve any type of coding question you may have. Easy to medium to hard to advanced, but in this case it's medium. I solved it already, so I just want to break down how I solved it and how you guys can also implement this type of tactic into any type of coding question. So in general, there are 4 steps to take in software, hardware, any type of technical type of question you may have by yourself or in an interview with a business, right? These 4 steps, and I'll go by one within the video. The first step is to read the question. It could be with modules, it could be with implementation, it could be with anything you may face within a technical type of question, technical problem, coding problem, whatever it is. It's to read a question, understand the question at all costs, because if you do not understand the question, everything else will fall apart. The whole foundation won't be steady. You must understand what you are solving. So let's go ahead and read this. Given a linked list, swap every 2 adjacent nodes and return its head. You must solve the problem without modifying the values in the list nodes. Only nodes themselves may be changed. So an example right here is 1, 2, 3, 4. It's in a type of array within your inputs and outputs, but they are list nodes described here in a definition of a singly linked list. So once you go through your solving right here, and we'll go into the pseudocode and the programming language we'll be using, which is Java. The 2, 1, 4, 3 is where we swapped each adjacent node. So in the input is 1, 2, 3, 4. These are all nodes within your head, and then now it's output 2, 1, 4, 3. Right? So each and every head is going to have its own number. All right. So in example 2, we have an empty, let's say, list node, and now it's returned back to empty. And then if we have only one head number, it's a value of a integer, you'll be given back a output of 1. So in general, these are your cases, and these are the most important cases that you will be having in this specific problem. And then the constraints, which is also important, the number of nodes in the list is in a range of 0 to 100, and also the 0 to less than or equal to the node value and less than or equal to the 100 is also important as well. So understand the constraints, understand the examples, and the main question of the problem, right? Very, very important, because if you do not understand the question, the foundation shall fall apart. So let's go ahead and write this down, because if you do not understand it and don't write it down, everything will fall apart. All right. It is very important within a technical interview, within a business, within any endeavor you may face in hardware and software and computer science and technology. So engineering, mechanical engineering. And I would say this is very important to write down the problem. So let's go ahead and do that. All right, once you write down the problem, you also want to write down cases / examples. It's always a good idea to make your own cases or go by the cases that are given within your interview. But in general, use some cases to understand the problem more and to go about it in detail when explaining it and understanding it for yourself. All right, once you write down your cases, go over the cases with your team, with the interviewer, with yourself, over and over again until you understand it, because each and every step, these 4 steps, are chronological, they are in order, and each one is important to each and every other. So the second step in solving any type of coding problem within hardware, software, whatever it is to also do some pseudocoding. So you wrote down the question, you understood it, you read it, you have your cases, and you also have your inputs and outputs. Also do your pseudocode as well. Pseudocode is basically where you are solving a problem, or you could be constructing a formula, any sorts. You're also doing pseudocode inside of mathematics as well. That's honestly some of the foundations of pseudocode, but in general, pseudocode is to construct a type of formula. So in this case, we are solving a problem. We are secretly writing down each and every step that we're doing, and we are doing it to the best of our ability without using the programming language. So it could be Java, it could be Python, but we are solving a problem without the programming language in our case. But pseudocode is very, very broad and very vast within technology. So let's go ahead and do some pseudocode. In this case, we generally want to look at each part that is very important. So since we want to make sure the node is full and it has at least more than one head to it, we want to do the reverse. So we want to check for something to, let's say, exist, and then we want to return or do something else to it. So since we want the list node to not be null and to not be null at the next, let's look for something that is null and look for something that is null at the next. So in general, if, put it in human terms, if you didn't understand that, I was talking very high level. If head is null, or the head length is null, let's say, and then I put commas to do another action of any sort. So in this case, return head, right? So, and I'll do all the pseudocode straight, and then I'll do the programming language to solve it. So we are solving it, we're just not using a programming language, we're using pseudocode, which is very vast and very broad. So we want to check for something is null. So if the head is null and the head next, I meant to say head next is null. So sometimes you might have some hiccups. That's why it's always good to have some pseudocode up ahead. Next part, and I put a space in between. This depends on your style of coding, but in general I put a space in between each one. So the next part we want to solve. So there are many parts you want to solve within one particular question. It could be a function you can make, which is a inner function within a function. There's different pieces you want to construct. So in this case, it's not too big, not too crazy. We want to solve many problems within one problem. So the next part, we want to establish variables. In my case, in the way I solved it. So I'll use establish. So established second and third nodes. We're not looking at the first and second, we're looking at the second and third, and I'll go into that while I explain the ending of the pseudocode and into the third part of these steps. So let's go ahead and make a type of list node and make a variable call of second node and a head next. All right. Once I get real into it, I sound real nerdy. All right, real nerdy. And the type of list node and a third node right here. When you say node, it just makes you sound real nerdy. All right. And then this is actually using the memory that we have, which is the second node. It's looking at the next. All right, and I'll explain this in a little bit. Next part, we want to do a second node. So, and yeah, I did say, I get real into it. I did say I was gonna do the pseudocode straight, and I'm very advanced within programming in the software and hardware type of area of computer science. So if I get into it, I just start solving something because I'm nice at the game like that. All right, so let's stay within the pseudocode and let's solve the next part. We have these variables, right? And I somewhat kind of wanted to do that to explain the next part. Our second node is going to be used in the sense of having it equal to the current node, right? So I'll write it like this. We'll have the second node next. Second node next equal the head. So in our current head, we want our second node next to equal the current head. All right, so let's move on. And like I said, I'll get real into it. I'll have the some of the solvings already there because I'm mad nice to the game like that. So of course I have been at it for a very, very long time. The next part, we want to use an advanced type of way of solving a problem, right, within programming. You know, and you can use this within Java, Python, C#, C++, and it's not dynamic programming, it is recursion. When we use recursion, it is then recalling the same function within itself until to a point where you can't call it anymore, right? So it's really useful in terms of binary. You guys can check me in the comments, let me know down below, and binary search trees and in a few other examples here, and in singly linked lists and doubly linked lists. So in this example, we want to use recursion to now look at the third and recall it and have that equal to the head next. So I might be talking to the right, I might be talking to the left. In this case, I talked to the right twice in a row. This example, me talking to the left, we're going to have the current head next equal the name of it. So the swap pairs, having it equal to the method call and using the third node. So you'll have to be able to talk from the left and the right within any type of interview and any type of business, right? And being able to be vast in your explanations, because if someone doesn't understand the way you're speaking in terms of how you're explaining it, you have to explain it another way, right? So I gave you two examples of explaining it. So in this case, we're having these swap pairs being returned using the third node and having it equal to, having it as a value equal to head next. So in this case, head next. So I'm basically reversing back and forth how I'm explaining it. This is very important when you're in a technical interview, is explaining it in multiple ways, especially being ready to answer questions when they don't understand you, right? So use recursion, right? So use recursion to make the head next equal, let's say in this case, we're just going to use this, the name of it, swap pairs, and of the third. And when you do of, you just write the actual word of within pseudocode of the third node in memory. So, and then after that, finally we return. So that's why it's not too crazy from what I was explaining. I'll just do the actual pseudocode of it then. It's not too crazy. We're not doing an inner function. We're just doing a straight recursion at most. We have that piece, and now let's solve it within our programming language, which is the third step. The third step you can interchange. If you're really advanced like me, you can go ahead and start solving it after each and every pseudocode you've done. But it is best, especially in harder questions, since this is easy, I've done that within here. It is easier to do all pseudocode and then do all programming language after. So whatever you're going to use, I'm using Java. Let's go ahead and solve each and every pseudocode piece. So if head is null or head next is null, return head. And doing it like this is really easy. You know, it's a lot easier to say, but nothing is easy. You just make it look easy. You know what I mean? So let's go ahead and go by the programming language itself. So here we're looking at the head, the current head, if it's equal to null, or we're looking at the next null, which is the head next, if it's equal to null. I'll go OG. You can put it in one line, since, correct me if I'm wrong in the comments, since Java, was it Java 9 and up or Java 8? Because I know Java 8 was the lambdas. Let me know in the comments that you can do a one-liner like this, but I'm gonna go OG and use brackets and do return of head. All in all, does the same thing. All right, let's go ahead and go to the next. Since I've done the next already, I'll explain this a little bit more. The established second and third nodes. When you establish these second and third nodes, you are then looking at it in memory and then having it tied to a particular value. So that's exactly what we're doing here. the type of list node, second node equals head next, and then the list node third node equals second node dot next, which is equal to the third node, and then the current head looking at the next is equal to the second node. So being able to explain it left and right is very important. If you're only one dimensional and you're explaining, depending on the company, depending on the business, depending on your projects, they're not really going to survive. More like, so I'm choosing to be more blunt in my videos now. So all right, and then the second node next is equal to the head. So the head next is also, well, the head itself is equal, call myself there, is equal to the second node dot next. So being able to explain it left and right. When you're doing this, you are then now doing exactly what I just said. That's why it's so good to name your variables of what you're trying to do or what is going to be. So the second node in memory, looking at the next, is equal to the head. All right, let's use recursion in this second to last part. Using recursion here, basically what I was saying is having to call the method itself, so the swap pairs, and having the argument, let's use argument this time, as the third node, and having that equal, having that be the value of the head, which is next, right? And then we return the second node, which is what we have in memory, right? So our head next is now this, and I like explaining it like this because it helps somewhat of a imbalance within math, within college math, within bounds in algebra, college algebra. You'll have to look at both left and right or the middle, whatever what you're doing in that type of question. So you have to be able to look at both sides at times when solving a problem. You can put it that way too. And using the third node in this case, right? And I'm making sure, since I'm in Java, I have all my semicolons. Okay. And then let's lastly return a second node. I just wrote second. Be very clear in your pseudocode as well, because some companies actually care deeply about the pseudocode that you're doing. So if you write second, they may not know what second is to the specific problem, because they only know second node based on what you're doing. And some of them might be real stiff and real butthurt, but the cases might matter too. So just saying that too, based on what you use as a variable. So let's return second node right here, which is in memory, but then we're having our head next, which is what we're looking at, equal these swap pairs third node. So awesome, cool. That's how you solve it. Let's go ahead and run it. Right, and you will run it in this third step and see if it works over and over again based on the programming language you are using. But you first look at the step 2 to see if it works within your mathematical pseudocode breakdown. So whatever you use in pseudocode, I use the standard basic pseudocode. I didn't use the discrete math pseudocode. I just want to keep it simple for this video. If you guys ever wanted to see that, let me know in the comments and or the Discord, which is down in the description as well, that we can break this down to advanced pseudocode using discrete math, and also doing the same thing in this particular problem or whatever problem we may be using. We can use different levels to solve many problems, which is amazing. So which goes back to one of the other points I was saying, that this is a medium problem. This can be for easy, medium, hard, whatever. These steps are foundational into solving any type of problem. So making sure it is solvable in your second and clearing that up in the third step, which is the programming language. The fourth step and the last step is to optimize, right? Optimize.
Robots out.
Basically get the fastest time. The fastest time is the shortest time within software development, and to make sure the least amount of space is used up in your cache, towards your server, in your database, whatever the case may be. So we're just looking at time for now, the time complexity, and based on what was read here, I got a 0 ms, and they're only looking at ms, which is the milliseconds. It goes from seconds to microseconds to milliseconds, but in general, you want to look at those 3. The nanoseconds isn't too important unless you're doing something really specific, but let me know what general case you'll look at the nanoseconds. But you're looking at microseconds, milliseconds when you're doing these type of cases of time complexity and space complexity. So let's go ahead and submit this. It is fully optimized based on what is needed for this particular problem. So let's go ahead and submit it. I'm out here saying optimize and optimize. What am I saying? Long day. But it is fully complete. 0 ms, 0 milliseconds. Nothing else to solve in terms of optimizing the code. In general, if you guys have any questions on this particular problem, let me know. If you have any adjustments, anything you could improve upon within this. I know you can break this down to different lines, minimizing the lines. Like, for example, here, we can take this out. All right, let me just go ahead and copy that, take it out, and we can one-line it. We're just doing the same exact thing. It just looks more attractive to the eye, and we can submit it, and hey, look, it's doing the same exact thing. So, boom, right? We got the same thing, 0 ms. So in general, let me know if any type of adjustments or clarifications, feedback, constructive criticism is welcome. Say something, do something, mean it with, if you have a chest, I don't know, mean it with something, and back up your studies, back up your knowledge with facts, articles, whatever you may need, especially within the Discord, since you'll be able to do different links in there. And let me know in the comments too down on this video. So I appreciate you guys watching. Thank you for coming through. Definitely subscribe, like, and share. Keep up with the Discord. We can do hackathons. I do a lot of gaming. We do a lot of stuff with technology in general. So definitely let me know. Go ahead and join up. If you have any clarifications, any feedback, any questions, let me know in the Discord and our YouTube community, and we'll definitely get right to it. These are the 4 steps onto solving any type of coding problem in general within hardware, within software, anything in computer science and even technology. So engineering, mechanical engineering, solving any type of problem with these 4 steps. These are the foundational steps you need to solve any type of technical problem in any scenario. So thank you for watching. Thank you for coming through. Take care and peace out, and I'll see you in the Discord.